Hi, welcome to Casual F Sharp, and this time we're going to be talking about passing functions into other functions and returning functions from functions, which sounds a little bit crazy if you're not familiar with it, but this is a very practical thing actually in F Sharp, and a very simple thing, and this talk stems out of a conversation I had with someone at work this week who was just beginning their journey into F Sharp and was stumbling slightly over the concepts here. This talk is going to move away a bit from the stuff we've been doing recently with rendering pictures of building files. We'll get back to that, but this particular time we're going to talk about some really basic bits of syntax and concepts. So it shouldn't be too long. Stick with it. So let's do a little bit of very fundamental revision. Let's have a let binding. We're going to make a function called add, and we're going to give it those parameters or arguments. And it's going to do something very trivial. You should be pretty familiar with that. And we can send that to F Sharp Interactive. And then I can say something like, well, let's do it up here so we've got it. Let's say let x equals add 5 and 4 for the sake of example. And not surprisingly, that gives us 9. Now I said before this was taking two parameters, but actually we can think of it in another way. Let's say let y equals, let's just leave one of them out. Now F Sharp's a strongly typed language, so it doesn't let you get away with much, but here this doesn't seem to be an error. If we just send that to interactive, bit mysterious, we've got something which takes an integer and returns an integer if you remember your function signature syntax. So what we're saying here is if you call a function you've defined with fewer parameters than the function expects, then you'll get another function which takes the remaining parameters. So in this case, y is a function which takes an integer and returns an integer, and we can prove that by saying something like y4, and lo and behold we get 9. So that's the first thing you need to understand in understanding how F Sharp syntax works, and it's a concept called, well, the separation of the two arguments is called currying, and the creating of a function by only providing some of the expected arguments is called partial application. Let's introduce another concept. Let's say we've got a function called do something. It takes something called f, something called a, and something called b. None of these is particularly useful in its own right, by the way. This is purely conceptual. And then I can say f, a, b. Well, that just seems a little bit strange, but if we send that to interactive, it takes something called f, which itself takes some type and some other type and returns a third type. Those, of course, might not be the same thing. And then this do something function requires a parameter called a, which is this first type, and a parameter called b, which is this second type. So let's say let z equals do something. Now we need to provide a function, and if you want to provide a function without giving it a name, you can just say fun, and then the parameters, let's make those w and v. And let's say we just multiply those together. And then we need to provide, or we can provide these two things here. Let's say we call those 2 and 3. Try and guess before I press Alt Enter what z is going to be. It's 6. So here we've passed a function in to do something and a couple of other values, and it's then, because the body of the function is this, it's actually called this function providing values a and b into w and v. So this is an anonymous function, and this is one of the ways you can pass a function into another function. So we could provide a different function in. Let's call this, I don't know, d. And this time we will add w and v. There we go, we get 5. Let's look a little bit more into how you return functions and the kind of things you could do. Let's make a function that itself creates functions. And what it does, it's going to return a completely different function depending on the value of the x parameter. So we're going to say if x is less than 50, then we're going to make ourselves an anonymous function. Doesn't really need a name because we're going to return it straight away. And this one is going to do adding. Just to emphasize, none of these is a particularly useful function. Otherwise, we're going to do multiplying. Okay, so this is a function which takes an integer and returns some other function which takes an integer and another integer and returns an integer. Try that out to make it clear. Let's call that, let's say, let's do that with 49. So in terms of types, f1 and f2 are the same type, and both of them are functions, which means we can call them. And we'll call both of them with the same arguments. So we'll send those across. Then we'll call f1 6, f2 8. So you can see that different branches of your, as it were, factory function can return different functions, but of course they have to have the same type signature. So let's say we try and do this. That's an error, and the error actually, as it happens, manifests itself here. But the issue is simply we're trying to return two different types. In one case, a function that takes nominally 3 arguments, and another function that takes 2 arguments, and we're trying to return them from the same function, which isn't allowed. So the real point of this is that in F#, functions are truly first-class values. In other words, you can pass them into other functions just as you could integers or strings or floating point values, and you can return them from functions, again, just as you would integers or strings or floating point values, and there's no additional syntax or ceremony around doing that. You just pass them around. And this has some interesting consequences. For instance, I can make a dictionary of functions. I'm going to start with a list, and the list is going to contain tuples of strings and anonymous functions. I mistyped that. And then we'll finish the list, and we'll just pipe it to this built-in function called dict, which will make that into an iDictionary. So if we send that to F# Interactive, and then we can say something like, we're going to use array-like syntax to access the minus element of that dictionary, which is a function. And it's a function that requires 2 arguments, so I'll say 2 and 3. And there we get 2 minus 3, which is minus 1. If we access a different element of the dictionary, which is a function, we get the result of calling that function. Now, the way type inference works is it uses the kind of simplest case, and the simplest case derived from what's going on here is that a and b are integers. Now that means if I do a divided by, I'm going to get 0 because we're doing integer division there. If I want to override that, I will just need to open a namespace, and I need to actually specify the type of the dictionary, which we can do just here. It's going to be an iDictionary with a generic parameter of string, and then each function, let's say we want to work in floating point, is a function that takes a floating point and takes another floating point and returns a floating point. So if we just resend that to F# interactive and just do that same thing, which is calling the entry called divided by, we get an error if we provide 2 and 3, but if we provide 2.0, in fact you can leave the noughts off if you want to, you get 0.6 recurring. So you can pin down the types of things if you want to, or you can let type inference do your work. It really depends on how you think and how you want to specify things. So for instance, back here, again, this was a bit looser perhaps than we might want. So we might want to say that f is something which takes a float and another float nominally and returns a float, which means again, when we actually come to call that function, we'd actually have to use floats. So just to emphasize, if you want to override type inference because you want to work, as it were, from that end of the stack, that's absolutely fine. It depends really on where you are in your design process and the kind of function you're defining. So just to reiterate, you can make a function that just does something and you can just call it. If you call it with fewer than the arguments it's defined to expect, then you get a function back that takes the remaining arguments. A parameter can itself be a function, and you can populate that parameter at call time using an anonymous function if you want, or you might feed in some function which is defined with a name elsewhere. A function can return other functions, so long as the function it returns, if it returns different functions, all of them have the same signature. You could even have a dictionary of functions if you want. So the key concept here is that a function is just a value. It's subject to the typing rules and typing consistency rules of any value, and there's no extra overhead really around defining functions, passing functions into other functions, or returning functions. They are just values. Okay, well, thanks for listening to Casual F#. See you again soon. Bye.